In Work Package 13, we've been working on a robotic and automated lean execution system. Previously, in Work Package 10 of In2Smart, a concept demonstrator of a robotic platform for maintenance was developed. The objective of Work Package 13 of In2Smart 2 is to use this work to further develop a reusable command and control framework. Here, a small autonomous wheeled vehicle will be demonstrated, with robotic maintenance capability designed to operate during track possessions, where no service trains are running. This will be extended to an example maintenance action for the robot. Now we will show videos of our progress on two vehicles using ROS, Robot Operating System, for integration. The vehicle can operate on or off the railway track. It needs to operate smoothly and safely. The vehicle is equipped with a 6 degrees of freedom arm. It can gather navigation data and use location and mapping technologies. A custom rail trolley has been built for working on the railway. The vehicle has been programmed to behave cooperatively. It keeps a distance from this obstacle. The vehicle sensor pack includes LiDAR for detecting objects near to the vehicle. The LiDAR generates a point cloud which interprets the immediate surroundings. The robot wrist camera is programmed to detect QR codes, which are used to simulate a fault location. The vehicle detects a simulated fault location on a railway track and makes a simulated repair.
This demonstration shows the autonomous AlumiCart railway robot. When it detects a moving obstacle with its sonar sensors, it stops. It waits for the obstacle to disappear. When the path is free again, it continues to navigate using odometry to a predetermined location. Once it arrives at the destination, it stays there for a while. It will then move back to the original location again, where it will stop.